Okay, so it looks like we have good evidence, at least supporting the contention, that the force is some multiple of the cross product, right? Because we did determine by orienting the magnet in one direction, the current parallel to the magnet, knowing that the direction of the field was either away from or toward the magnet, and we haven't yet distinguished between those directions, right? And we don't know whether the current's this way or this way because we haven't distinguished that. We haven't defined that. Okay, well, that was defined for us a couple hundred years ago. So we're going to use that definition, but we're not there yet. We haven't measured that. We determined that in that situation, the wire wanted to move this way or this way, depending on which way you had the current running. And also that if you reverse the magnet, those directions reverse. Okay? So you saw all that, and that was very good. So we have good plausibility that the force should be proportional to the cross product of current and magnetic field. Okay? Now all the details of the cross product, you know, with the sign of the angle and stuff like that, yeah, we haven't measured that, and we probably won't. We're just going to kind of accept this. Okay? And also, K prime in SI units turns out to be 10 to the negative 7th. What should the units be? Well, I haven't told you what the units of magnetic field are. I have told you what the units of current are. What are the units of current?
No, charge over seconds.
Charge over?
Time.
Yeah, I think you started to say it. Finish the word.
Amps. Yeah, it's seconds.
Huh?
Time, seconds.
Yeah. Charge per unit of time, which is amps.
Yeah.
Okay, when the charge is measured in coulombs and the time in seconds. Now it turns out that amps is one of the 4 fundamental quantities in physics, along with time, seconds, in SI units, length, meters, in SI units, and mass, what's that, pounds or slugs? Oh yeah, kilograms, right?
Yeah.
So your basic units in SI are kilograms, meters, seconds, and amps. Okay? And you do this whole physics course with those units. So K prime has to give you units of force, so it has to give you newtons, right?
Right.
So it's got to be newtons,
This means
but then you got to divide it by units of current times units of magnetic field, right? So that's amps times Tesla, and Tesla is just the magnetic field that will give a 1 amp current a 1 Newton force when it's aligned perfectly, okay? So you can break Tesla down to kilograms, meters, seconds, and amps, okay? You don't need to know that. We're not really studying magnetism now. We're using magnetism in this case to indicate our current.